Hi everyone, in this video I'm going to solve A-Levels Pure Mathematics Paper 1 in a session May-June 2024 Paper 1-1. So let's start with the first question. Question number 1, part A, express this quadratic expression in terms of the vertex form where A and B are constant. So this is a quadratic equation. This is a standard form of a quadratic equation in a variable y. We have to convert this into the vertex form. So let me write down the standard form of a quadratic equation, which is ax square plus bx plus c equals to 0. This is my standard form of a quadratic equation, and the vertex form is a into x minus h whole square plus k. This is my vertex form where h and k is the vertex. This is the vertex. All right. Okay, now we have given the standard form, which is 3y square minus 12y minus 15. We have to convert the standard form to the vertex form. Okay, so whenever we have to convert the standard form to the vertex form, we have to use a method of completing square. Completing square method. So in the completing square method, the first step is to take the coefficient of the y square or x square. You have to take that common, right? Basically, you have to take the a common from the first and the second term. So the coefficient of y square is 3. So we have to take 3 common from the first and the second term. So when I'm taking 3 common, so basically I have to divide first and the second term by 3. So this becomes y square, and 12 divides 3 is 4. So negative 4y and negative 15, the third term, is outside. So that is the first step of completing square method. All right, now in the second step we have to complete the square inside the bracket. So how can we complete the square? We have to take the coefficient of y, which is negative 4, divided by 2. Every time you have to take the coefficient of y or x, whatever the variable you have over here. So take the coefficient, divide that number by 2, and you will get some number which is negative 2, and take its whole square, which is equals to 4. So now you have to add and subtract 4 inside the bracket. So 3, we have y square minus 4y plus 4 minus 4 and negative 50. Now combine the first 3 terms with a positive. So 3y square minus 4y plus 4, and the last term is 3 into negative 4, and minus 15 is outside. So this is 3. Okay, now let me complete the square. This is y square minus 2 into y into 2 plus 2 square. What I did inside the bracket, the first term square, I did a minus b whole square over here, right? So look closely. So first term square minus 2ab, minus 2 times the first term is y and the second term is 2, and 4 is the square of 2, and this is negative of 12 and negative of 15. So when I complete the square, a square minus 2ab plus b square is a minus b whole square. So y minus 2 whole square, and minus 12 minus 15, this is negative 12, negative 15 is negative 27, negative of 27. So we have to express the standard form into the vertex form where a and b are the constants, and this would be in the vertex form. This is 3y plus a whole square plus b. So a value is negative 2 and the b value is minus 27, and these two are constants. Now moving to part B, hence find the exact solution of this equation and put it equals to 0. Okay, so look at the equation in the A part. So we have this equation, 3y square minus 12y minus 15. Now we have 3x to the power 4 minus 12x to the power 2 and minus 15 equals to 0. So before we have 3y square minus 12y minus 15, we did this as 3 into y minus 2 whole square minus 27. And now what we have 3x to the power 4 minus 12x square minus 15. Okay, now this means we have y square would be equals to, or we can say y equals to x square. Here y equals to x to the power of 2, right? Okay, so this is 3x square minus 2 whole square minus 27. So we have to solve this and put it equals to 0. Find the exact solutions. Okay, now put this equals to 0. We have 3 into x square minus 2 whole square minus 27. This is equals to 0. So 3x square minus 2 whole square equals to 27. Dividing both sides by 3. So x square minus 2 to the power of 2. This is 27 out of 3. 3 times 9 is 27. So we have x square minus 2 to the power of 2 equals to 9. Okay, so what I have to do, I have to take the square roots on both sides. So square root of this side and the square root of this side. So this square and square root is cancelled. We have x square minus 2 and this is plus minus 3. Square root of 9 is plus minus 3. Now we have two solutions. X square minus 2 equals to 3 and x square minus 2 equals to negative of 3. So here x square would be equals to 3 and plus 2. So x square would be equals to 5. And here x square equals to minus 3 plus 2. So x square would be equals to negative of 1. So we have to find the exact solution solving for x. So taking square roots on both sides, square root and the square root. All right, so this is cancel out. Here x would be equals to plus minus root 5. Okay, this is cancel out. Here x is equals to negative root 1. This is equals to iota and this is a complex root, and we are just working with the real roots in this course, right? So we have the only solution is plus minus root 5. Question number 2, the diagram shows two curves. One curve has an equation y equals to sine x. This curve is y equals to sine x. This one is y equals to sine x. And the other curve has an equation y equals to f of x. So this one is y equals to f of x, some function. Okay, now for part A, in order to transform the curve y equals to sine x to the curve y equals to f of x, the curve sine x is first reflected in the x-axis. Okay, so sine x is first reflected in x-axis. Let me reflect this. Okay, so when we have a reflection in x-axis, what does this mean? When reflection in x-axis, it means xy changes to x and minus y. So when we have a reflection in x-axis, the x value stays the same, the y values are reversed. So this x value and y value 0, 0. Here x stays the same, y becomes minus 1. Here again we have 0, and here we have, this is minus 1, this would be plus 1. And we have this point, yes, this point, I'm working with this curve. Okay, and the other curve to this point, and then minus 1, and again we have 0, and then we have a plus 1. Okay, let me reflect this down, and then 0, and then 1, again 0, minus 1, 0, and 1. Right, so this with the curve of the reflection. Now describe fully a sequence of two further transformations which are required. Okay, so two further transformations we need. Okay, now here the starting point is 0 and now the starting point is negative 2. So obviously there is a translation, vertical translation 2 units down. So it is a vertical translation 2 units down. All right, and what else? Okay, after translation we have something, we have a vertical stretch as well, because as you can see the x value stays the same, which is pi by 2. We have pi, we have 3 pi by 2. The x values are same, just the y values are different. So it means we have all the transformations are applied in y. So we have a translation, vertical translation 2 units down is the first transformation, and the second transformation is there is some vertical stretch by a factor of, we have to check what factor it is. Okay, So if I move the graph 2 units down, so now it starts from -2, okay, and from 0 it is moving to -2, right? And this 2 units down would be this, and these 2 units down is this point, okay. So 1 unit and 2 unit, this would be that point, okay. 1 and 2 units is this point, okay. Again 2 units, this point, okay. 2 units, this point. 2 units, we have this point, okay. So we have a reflection translation, 2 units translation, 2 units down, vertical translation, and there is a stretch in y direction, right, vertical stretch. Okay, so how much is the vertical stretch? We have to check the coordinates. Now this coordinate is equals to 0, -2, okay, and this coordinate is pi by 2 and -3. This coordinate is x is pi, y is -2. This is 3 pi by 2 and -1, and so on. Okay, how these coordinates are changed? This one is same. Now this coordinate, the x stays the same, pi by 2. Now this becomes -5, and the next is 3 pi, okay, this is pi, this stays the same. This one would be at 1, 3 pi by 2 at 1. Okay, so now let's apply the transformations. Okay, so we have the transformed equation is y equals to a sine b into x minus d and plus c. Okay, a is the, we can say, the vertical stretch, b is the horizontal stretch, d is the phase shift, and d is basically the horizontal translation, and c is the vertical translation. Since there is no horizontal translation, it is not translated horizontally, it is translated vertically, so we have to use a c value. All right, and we have a vertical stretch as well in y direction, not horizontal stretch. All right, so how the xy changes? Xy coordinates changes to x over b plus d into ay plus c. Okay, so x changes to x by b plus d. Since we are not, there is no horizontal translation, d value is 0. There is no horizontal stretch, b is just 1, right? Okay, so there is some vertical stretch as well. There is a vertical translation as well. Let's see how much is a vertical stretch. Okay, so we have the we know that we have vertical translation -2. Vertical translation is -2 because it's moved 2 units down, right? Now this point is, if let me deal with this point. So the point pi by 2 -3, and okay, let me deal with this one. Pi by 2 and -1 changes to pi by 2 and -5. Okay, so x value is pi by 2 and this is -1. So how it changes? X stays the same, pi by 2. So what is the y? So it changes to -5. Okay, so means the x coordinate is pi by 2, it stays the same. The y is -1, changes to this one. All right, and we have c value is -2. So we can say this is pi by 2. There is some a and the y is -1. This is y, and then plus c value is -2. All right, so this is pi by 2, and we have a minus 2. So what would be the a would be 3 to get 5. This is pi by 2. We have -3 and -2. This would be equals to 5. So pi by 2 and -5 are the coordinates. Yes. Okay, so it means we have two transformation. Number one is vertical translation. Vertical translation 2 units down. So we have 0 and -2 is the translation, and we have a vertical stretch. vertical stretch by a factor of 3. Okay, so let me explain this one more time. So first, whenever we have to find the transformations in a periodic functions or a sinusoidal function, sine, cosine, so we have to use this equation, the transformed one, and then we have to check the coordinates, because in this case we have given the coordinates. If we have amplitude, phase shift, then we can have to use other way, but here we have just given the coordinates. So you can see this coordinate after the first one is given after reflection, this coordinate 0 0 stays the same, but here this coordinate becomes pi by 2 minus 1 changes to pi by 2 minus 5. How it changes to pi by 2? It means x stays the same. There is a change in y. There is some a value, right, and the y is minus 1, and the c we know is the horizontal vertical translation, which is negative 2. So we got the a value, which is equals to negative of 3, right? Now for part B, find f of x in terms of sine x. Okay, what is f of x? So we have 3 transformations applied on f of x. The first is reflection in x-axis is the first transformation. The second transformation is translation is 0 and negative 2, and the third is vertical stretch. Vertical stretch, a value is positive of 3. All right, so we can write down y equals to, as we have a reflection in x-axis, it means y equals to negative of some f of x. The function should be negative. Y equals to f of x. This is minus, the a value is 3, and then we have a sign, the b value is 1, x and minus 2. We have a vertical translation 2 units down. We have a vertical stretch by a factor of 3, and we have a reflection as well. So for reflection, so we have y would be equals to y sine x, so it becomes minus sine x, right? Then we have a translation, y equals to minus sine x, and translation is negative 2. And then we have vertical stretch, y equals to minus 3 sine x and minus 2, right? First we have a reflection. The function is just put the negative sign with the whole function. Sine x become minus sine x. Then we have a translation, so add or subtract that vertical translation, so it is 2 units down, so it is negative 2. And for vertical stretch, we have to multiply your the function with that factor, like it's a factor of 3, so 3 is multiplying. So that would be the equation of the function f of x. Question number 3, the coefficient of x cube in the expansion of this is 160. Number A, find the value for constant a. Okay, so we have to find the coefficient of x cube basically. So let me open this. So the first term is 3 power 6, 6c1. We have 3 power would be 5, and ax power would be 1, plus 6c2. We have 3 power is 4, and ax whole square. 6c3, we have 3 power 3 and ax whole cube, up to so on. Now this is a constant term, this is x term, x square, and x cube term, right? So let me write down x cube term. X cube term is 6c3, 3 cube, and a cube, x cube. Let me simplify. What is 6c3? 6c3 is 20, and 3 cube is 27, and a cube and x cube, right? Now let me simplify. 20 times 27, this is 540, 540 a cube, x cube. Now compare the coefficients of x cube. We can say coefficient of x cube, this would be the coefficient of x cube. So 540 a cube, this is equals to 160. So a cube, this is equals to 160 divided by 540. Let me solve for a. 160 divide 540. This is 8 over 27. So a cube is 8 over 27, and 8 is a cube of 2 and 27 is a cube of 3. So cancel all the cubes. So from here a value is 2 by 3. Alright. Now for part B, hence find the coefficient of x cube in this expansion. Alright. So I already opened some terms of 3 plus ax to the power of 6. So the first term is 3 to the power of 6. Let me open. 3 to the power of 6 is 729 plus 6c1 is 6 times 3 to the power 5. Okay, ax. And a value is 2 by 3 times 2. Okay, 2 by 3. 972x. 972x. All right, and the next term I'm solving from here. 6c2 times 3 to the power of 4 times 2 by 3 square is 540x square. 540x square plus the next term we already did is this much. 540 times a cube, 2 by 3 whole power is 3, which is 160x cube, and plus so on, right? Let me multiply this with 1 plus 2x. So first times it by 1. So this term is multiplying by 1 minus 2x, right? And solving for the coefficient of x cube. Okay, so first we have to multiply all the terms by 1. This is a constant, this is x squared, this would be x cube term. So 160 is a coefficient of x cube, right? Now when we are multiplying with minus 2x, this would be the x term, this is x squared term, this would be x cube term. So minus 2 times 540. These are the coefficients of x cube. Okay, minus 2 times 540. 160 minus 1080. 160 minus 1080. This is minus 920. That would be the coefficient of x cube. Question number 4. The equation of a curve is y equals to f of x, where f of x equals to this. This is the equation of the curve. The following point lies on the curve. These point lies on the curve. Non-exact values have been given correct to 5 decimal places. A, B, C, D, E, F. These points lies on the curve. Number A, find the value of K. Give your answer correct to 5 decimal place. Okay, so we have given the information that the point lies on the curve. It means B lies on the curve, right? B lies on the curve. All right, so if B lies on the curve, it must satisfy. So x is 2.0001 and the y value is k. So let me put over here, this f of x is basically y. So y value is k. 2 into x is 2.0001 minus 1. Square root of 3 into 2.0001 minus 2. And outside we have negative 2. Let me simplify this. Okay, 2 times 2.0001, we have 3 zeros, yes, minus 1 bracket and bracket square root of 3 into 2.0001 negative 2. Sorry, outside we have a bracket and subtract 2. We have up to 5 decimal place. We have to solve for k. 4.0006. 1, 2, 3, 4, 5. 2 5, so rounded to 3. 5 decimal place. We have to find the k value. Now the table shows the gradient of the chord AB, AC, AD and AE. Chord we have given and the gradient of the chords we have given. Number B, find the gradient of the chord AE. Give your answer correct to 4 decimal place. Okay, so A is the point which is 2, 4 and E is the point which is, this is the point E. Let me rewrite. 2.1 and 4.63 566. Let me solve the gradient, which is y2 minus y1 over x2 minus x1. This is y2, this is y1. 4.63566 minus 4 over 2.1 minus 2. Okay, 4.63566 minus 4, and this is divided by 2.1 minus 2. This is 6.3566. 6.3566. This is up to 4 decimal place. Yes. Okay, let me complete the table. 6.3566. Now for part C, deduce the value of f prime of 2 using the values in the table. F prime of 2. This is the gradient of the function. Gradient of AB, B, AC. These are the gradients. We have to find the gradient of the function at point 2. We have to guess the value with the help of the table. So as you can see, we have a gradient of the points A, B, A, C, A, D, A, E, A, F. So all the values are with A. So A has x2, 4, and then 2.0001, 2.001, 2.01, so 2.1, and then 3. So we are not taking the 3. So these values, which the gradient is closer to, 6.2501, 6.2511, 6.26. Okay, 6.25 is the gradient that I guess, because this is closer. We have 6.25 and then 01, 6.25, 11, 6.2, 601. So the accuracy is 6.25. We can say f prime of 2 from the table is 6.25. Question number 5, part A, prove the identity. So starting from the left hand side, let me prove this identity. What is sine square? Sine square is 1 minus cos square x. I'm using this identity, that sine square x minus cos square x equals to 1. So what is sine square x? So from here, sine square x plus cos square x is 1. This is 1 minus cos of square x, right? So I use the value of this sine square x minus cos x is as it is, minus 1 is as it is, divides 1 plus cos x is as it is. All right. So plus 1 and minus 1 is cancel out, right? We can take a negative sign and cos x common. So we are left with 1 plus cos x divides 1 plus cos x. So we can cancel the like factors, which is 1 plus cos x and 1 plus cos x, and we are just left with minus cos x. And that is my right hand side. It is proved. Now the next B part, hence solve the equation. Okay, so from the first part, we have sine square x minus cos x minus 1. Sine square x minus cos x minus 1. And here we have 1 plus cos x. In the denominator, we have 2 plus 2 cos x. Okay, so we have sine square x minus cos x minus 1 over, let me take 2 common, we have 1 plus cos x. So the answer to this term is minus 1 by 2, we have cos x. This holds the answer other than 2. This is minus cos x and this is 2 in the denominator, right? And we have to put this equals to 1 by 4. And we have to solve when x is between 0 degree to 360 degree. 2 times 1 is 2, 2 times 2 would be 4. So from here we can say cos x is negative of 1 by 2. So now cos is negative, right? So let me simplify. So x would be equals to cos inverse of half. Let me solve, get the value for the positive. It's in degrees already. So cos inverse of half is 60 degrees. So here x is equals to 60 degree. Now cos is negative. Let's see in which quadrant cos is negative. If I can draw the cast rule. Let's recall the CAS rule. C, A, S, and T. So cos is positive in the first and the fourth quadrant. Cos is negative in the second quadrant, and in the third quadrant it is negative. And the operations are over here. We have 180 minus theta, and here we have 180 degree plus theta. All right, so let me simplify the solutions. So in the third quadrant, cos is negative, and the value of x would be in 180 degree subtract 60 degree, and in the fourth quadrant cos is negative, so the new x value would be in 180 degree we have to add this value 60 degree, right? 180 minus 60 is 120. 180 plus 60 would be 240. So these are the two solutions and they belongs to 0 to 360. Question number 6. The function f of x is defined by, this is the function for x is less than 0, all the values of x which are less than 0. Alright, the diagram shows the graph of y equals to f of x. Part A, on the diagram, sketch the graph of y equals to f inverse of x, show any related mirrored line. Okay, so mirrored line is y equals to f of x. We can do a reflection. This would be the mirrored line. Okay, yes, that would be the mirrored line, right? So this is a graph of f of x. Now what would be f inverse of x? So as you can see, this is closer to y, and our inverse function should be closer to x, and it is far from x, so it is far from y. So this would be closer to the x, right, and it is far from y. This would be the graph of f inverse of x. All right, now for part B, find an expression for f inverse of x. So let me solve the expressions. Okay, so here y equals to f of x, which is 2 over x square plus 4. Now switching the variables, we can say x is equals to 2 over y square plus 4. Solving for y, so x minus 4, this would be equals to 2 over y square, or x, okay, so y square over 2 over x minus 4, just doing a cross multiplication, and y would be equals to plus minus root 2 over x minus 4. All right, so this is my f inverse of x, but we have to pick one value, whether it is positive or negative. So look at the graph f inverse of x. What are the outputs for y? So all the positive x values, the output of y's are negative, so we have to put the negative ones, right? So we can say f inverse of x is equals to negative root 2 over x minus 4. Okay, now for part C, solve the equation f of x equals to 4.5. f of x equals to 4.5. 2 over x to the power 2 plus 4, and this would be equals to 4.5. We have to solve for x. So from here we have 2 over x square, this is equals to 4.5, subtract 4, and that is 0.5, right? 4.5 minus 4 is 1 by 2, right? Now we can switch, take the reciprocal. 2 by x square, 1 by 2. The reciprocal is x square divided by 2, and this would be 2 by 1. So cross multiplication we have, and here we have x square would be equals to 2 times 2 would be 4, and what is x? Root 4 is 2. X is equals to 2. So the solution is x is equals to 2. Now look at the graph. As we know that x should be less than 0, all the values of x should be negative, so it is not positive 2, it is negative 2, right? Okay, so we have explained why the equation f inverse equals to f of x has no solution. So you can see this is f of x, this is f inverse of x. There is no point of intersection, the curve do not intersect. F of x equals to f inverse of x has no solution, no solution. as the curves do not intersect. Okay. Question number 7. In the diagram, AOD, and BC are two parallel straight lines. Arc AB is a part of a circle with the center O and radius is 15 centimeter. OA is 15, OB is 15. Okay. Angle BO and A is theta radians. Arc CD, C to D is an arc, is a part of a circle with the center O and the radius is 10 centimeter. OD is 10, OC is 10. Angle COD is pi by 2 radians. COD, this is pi by 2 radians. Okay, now for part A, show that theta is 0.7297, correct to 4 decimal place. We have to solve for this theta. All right, so we have this angle is this is a straight line, so we know that angle on a straight line is equals to 180 degree. This is pi by 2. Let me solve for this angle and then adding the two angles and subtracting from pi by 180, so you will get that angle, right? Because we have just these two sides. If we have an arc length, we can easily get the theta. Okay, so this is a right angle triangle. As you can see, this is a right angle triangle, that is a right angle. Okay, so if I can solve this angle, let's say this is alpha. What is that angle alpha? Okay, the angle alpha, opposite is not given, we have adjacent and the hypotenuse, so we can say cos of alpha is adjacent is 10 and the hypotenuse is 15. Let me solve for alpha in terms of radians. Alpha is cos inverse of 10 over 15. Okay, in radians, my calculator is in degrees, now it is in radian. Cos inverse of 10 by 15, yes, this is 0.841. Alpha is 0.8411, up to 4 decimal place, I round it. Okay, now we have an alpha, so we have theta plus alpha plus pi by 2 radians. This whole angle is equals to pi, so angle on a straight line is equals to 180 and 180 is basically a pi. Okay, let me solve for theta. Theta is from pi, take away pi by 2 and take away alpha. All right. Okay, so you have pi minus pi by 2 minus answer 0.7297 up to 4 decimal place. That is the value of theta. It is proved. Now moving to part B, find the parameter and the area of the shape ABCD. Give your answer correct to 3 significant figures. Parameter and the area we have to find for the shape A, B, C and D. So parameter of the shape A, B, C, D is basically sum of all sides, right? So this side is 15, this side is 10, so the whole side would be 25. We have to find this side and this side to get the parameter, right? So we have parameter is sum of all sides. Let me work on the parameter first. So we have this side A, O and OD. So this side is equals to 25. Let me solve for AB. AB is the arc length. So we have AB is the arc length, which is radius times theta. The radius is 15 and the theta is 0.7297. Okay, so 15 times 0.7297, 7297, yes. This is equals to 10.9455. Okay, so we have AB, which is 10.9455. Okay, now let me solve for CD. This is also an arc length. CD is an arc length, which is radius times theta. Radius is 10 and the theta is pi by 2. So 10 times pi by 2. 10 times pi by 2 is equals to 5 pi, or we have 15.7079 sorry, 7 9, this is okay, this is 5 pi was 15.70796. Okay, now what is BC? This is a right angle triangle again, so you can use a Pythagoras theorem, or you can use the ratio. You have alpha already, which is 0.8411. So let me use a Pythagoras theorem to solve for BC. So hypotenuse square is 15, and the other two legs are BC, its whole square, and we have 10. Let me solve for BC, which is 15 square minus 10 square. This would be equals to BC square. So 15 minus 10, 15 square minus 10 square, we have a square root of 125. So 5 root 5 is BC. Okay, this is 5 root 5. Okay, now let's find out the parameter A, B, C, D. Okay, so the parameter is going to be, we have 15 plus 10 plus 10.9455 plus 5 root 5 plus 5 pi. That would be the parameter. Let me simplify. 15 plus 10 plus 10.9455 plus 5 root 5 plus, okay, outside it's plus 5 pi. 62.83380. Up to 3 significant figures we have to solve. 62.8 is the parameter. 62.8 centimeter is the parameter. Now the next part, we have to find the area of that shape. So look at the shape. The area of the shape is area of the sector, area of this sector, and area of this right angle triangle. So we have to add them up to get the total area, right? So let me find area of sector AOB, which is half radius square theta. Now this is half, the radius is 15, its square, and theta is, we have theta is this 0.7297. 0.7297. Let me simplify this. So 1 by 2 times 15 square times 0.7297 is this much, which is 82.09125 centimeter square. Okay, the next area of this sector, let me work on. So we can say area of the sector COD, which is half radius square theta. So radius is 10 and theta is pi by 2. So half, we have 10 square and pi by 2. Okay, so we have 1 by 2 times 10 square times pi by 2. This is 25 pi. 25 pi. Okay, now let me find the area of the triangle OCB. Okay, area of triangle OCB. This is a right angle triangle, so its area is half base times height. The base is 5 root 5 and the height is 10. Okay, so 5 root 5 times by 10 divided by 2. This is 25 root 5. So let me find the area of the shape by adding all the three areas. So we can say area of A, B, C, and D, which is 82.09125 plus 25 pi plus 25 root 5. Okay, 82.09125 plus 25 pi plus 5 root 5. 25 root 5, sorry, 216.5. This is 216.53 and up to 3 significant figures, which is 217 centimeters square. Question number 8, part A. The first 3 terms of an arithmetic progression are 25, 4p minus 1 and 13 minus p, where p is a constant. Find the value of the 10th term of the progression. We have to find the value of the 10th term, and it should be in terms of p, I guess. Okay. So the first term, a, would be equals to 25, and what is the d? D is, we can find the 13p, 13 minus p minus 4p minus 1. So what is d? D would be, we can say, we have 13 minus p minus 4p plus 1. So here d is 13 plus 1 would be 14 and minus 5p. This is the value of d. And there is another value of d, which is, so the d value is basically the second term minus first term, and this should be equals to the third term minus the second term. So the third minus second is this much, and the second minus first would be 4p minus 1 minus 25, and this is equals to 14 minus 5p, and from here we can solve for p. So the 10th term is not in terms of p, right? So we have 4p, this is equals to 14 minus 5p, and here we have, this is minus 25, 6 as well. So combining the like terms, we have 4p and plus 5p. Here we have 14 plus 25, 6. This is 9p, and 14 and 26 add up to 40. So what is p? 40 out of 9. Is that in simplest form? Yes. So this is p. So the 10th term, we can say the 10th term is equals to a10 is equals to a plus n minus 1 into d. This is the formula for the terms. A is the first term, which is 25. N is 10 minus 1. And what is d? This is d. 14 minus 5p. D is 14 minus 5 into p, which is 40 over 9. Okay. So the 10th term is 25 plus 9 into, okay, 14 minus 5p. Okay, 40 times 5. Okay, sorry. 40 by 9 times minus 5 and add 14 is minus 74 over 9 times by 9 and add 25. This is minus 49. Negative of 49 is the 10th term. Question now for the second part B. The first 3 terms of a geometric progression. The first 3 terms are these, where q is a positive constant. Find the sum to infinity of the progression. So it is a geometric progression. Sum to infinity, S infinity is a over 1 minus r. A is the first term, which is 25. We have to find r. What is r? R is the second term over the first term, and that should be equals to the third term over the second term. Let me solve for r. The second term is 4q minus 1 over 25, and this should be equals to 13 minus q over 4q minus 1. Okay, let me solve for r over here. So we are doing a cross multiplication. So 4q minus 1 is multiplying with 4q minus 1. So 4q minus 1 whole square, and here 25 is multiplying with 13 minus q. So open this square. 4q, we have a square, plus 1 square minus 2 times 4q and into 1. This is 25 times 13 and 25 times q, right? 4 times 4 is 16 q square plus 1 minus 2 times 4 is 8q. This is 25 times 13 is how much? 325. 325 minus 25q. Combining all the terms, which is 16q square minus 8q plus 25q plus 1 and minus 3 to 5. This is equals to 0. So 16q square, from 25 subtract 8, 17 minus plus 17q and minus 3 to 4, take away just 1. This is equals to 0. Now that is a quadratic equation. We have to factorize or solve by quadratic formula. Factorization is hard, so let me solve by quadratic formula and solving for q. Q is negative of b plus minus square root, we have a b square, minus 4 times the a value times the c value, square root, this wholes divides 2 times of the a value, which is 16. Okay, let me simplify. 17 square, okay, this is 289, minus 4 times 16 times minus 324 plus 289, and square root of answer is this much. Okay, so q is minus 17 plus minus 145 over 2 times of 16 is 32. Let me solve for the two q values. What is the q? So minus 17 plus 145 and divided by 32, this is 4, and minus 17 minus 145 divided by 32, negative of 5.0625 with a negative. So these are the two q values, right? So in the question we have given that q should be a positive constant. So we are not considering the negative one. So we can say since q is a positive constant, so this implies q is equals to 4. Let me solve for r. From this equation we can substitute the q. So 4q minus 1 over 25. 4 times 4 is 16 minus 1 over 25, which is 15 out of 25. 5 times 3 is 15, 5 times 5 is 25. That is my r. Now let me solve for sum to infinity and plug the values. So a value is equals to 25 and 1 minus r is 3 by 5. Okay, 1 minus 3 by 5 and 25 divided by answer is this 62.5. That is the sum to infinity. Question number 9. The diagram shows part of the curve with equation y equals to this. Okay, and the line x is equals to 2.4 and y is equals to 1. The curve intersect the line. This curve intersect the line y equals to 1 at the point 1, 1. Find the exact volume of the solid generated when the shaded region, this shaded region, is rotated about 360 degree about the x-axis. Okay, the rotation is about x-axis. Okay, the rotation is about x-axis. So at this point x is equals to 1. Here x is equals to 1, and here this line x is equals to 2.4, right? So this shaded region is rotated about x-axis. It is a rotation about x-axis. So if we have a rotation about x-axis between 1 to 2.4, okay, let me explain you the situation. So as we know, here x is 1 and here x is equals to 2.4. So we have to find the volume of a solid which is generated. So basically the volume formula about it is a rotation 360 degree about x-axis. So the volume about x-axis, this is pi integration from 1 to 2.4, x is 1 and x is 2.4, the y it's square and with respect to dx. That is the formula, but this is the whole one, right? So what we are doing is the integration of this whole one from 1 to 2.4. Since we have to find the exact volume when the shaded region, just for the shaded region, so let me visualize this situation. This is a rectangle, right? Between this shape is a rectangle. When we rotate this shape 360 degree, so it make a cylinder, right? And the radius of a cylinder is, this radius is 1, and the height of this cylinder is from 1 to 2.4 is 1.4, we can say. Okay, so it looked like a cylinder. Let me draw that cylinder. Okay, because when we rotate this rectangular region, it shapes look like a cylinder. Okay, in most of the, some students have a question in their mind that why the radius is 1. This length is from 0 to 1. Why the radius is 1? Because this length is 1 and it is rotated again 360 degree. So it whole make a cylinder. So whole the upper portion this. So 1 and then 1. So it becomes 2. So we can say here the radius is equals to 1. I hope this is clear now. And the height would be, the height of the cylinder is from 1 to 2.4. This is 2.4 minus 1, that is equals to 1.4, right? Now let me solve the volume of a cylinder. Volume of cylinder is equals to pi r square h. Pi radius is 1 and the height is 1.4. Okay, 1.4 times pi we can say. So 7 pi by 5 is the answer, right? Let me explain this situation one more time. So we have given that here the x is 1 and here x is equals to 2.4. We have to find the volume of a solid. So the volume of a solid when it is rotated 360 degree. So this shape is a rectangle. So when we rotate the rectangle 360 degrees, so it makes a cylinder, and this would be the height of the cylinder. Height of a cylinder is from 1 to 2.4, which is 2.4 minus 1. The height is 1.4, and that is the radius of a cylinder. Why I'm taking this whole length as a radius? Because when I'm rotating this, so it make a circle, right? So now let me plug the values into this formula. So Vx is pi integration from 1 to 2.4. This is the function y, its whole square. 1 square is 1 over 5x minus 4, its power is 3 by 2, whole square is 2 by 3, and with respect to dx, right? So Vx is going to be pi integration from 1 to 2.4. We have 5x minus 4, its whole is minus 2 by 3, and dx. So let me apply the power rule of integration. So Vx is, we have pi, so 5x minus 4, its whole power is minus 2 by 3 plus 1 over minus 2 by 3 plus 1, multiply 1 over its derivative, which is 5, and no constant of integration because this is a definite integral, right? So what is Vx? Minus 2 by 3 plus 1 is what? I guess it is 1 by 3. Yes, this is 1 by 3. So we have pi 5x minus 4, its power is 1 by 3. This would be 1 by 3 times 1 by 5 from 1 to 2.4. So this becomes 3 by 5. Okay, so we can say Vx is equals to pi 3 by 5 into 5x minus 4, its whole is 1 by 3, and the limits are from 1 to 2.4. Now let me plug the limits. So Vx is pi 3 by 5, this is outside, So 5 times 2.4 minus 4, this is upper limit, power is 1 by 3. Subtract the lower limit is 5 times 1 minus 4, it is 1 by 3. Okay, so Vx is 3 pi by 5. Let me simplify the limits. 5 times 2.4 minus 4, its power is 1 by 3. This is 2. And 5 times 1 minus 4, and its power is 1 by 3. So which is 1. 2 minus 1 is 1. So this is just 3 pi by 5. Okay. And that is the volume under the curve, the same as we did area under the curve, right? Okay, now let me explain you the situation, what I'm going to do next. Okay, so we have done with the whole volume. This shape, x is 1, x is 2.4. When we rotate this rectangle, it becomes a cylinder, and that would be the height and that would be the radius of the cylinder. So we have done with the volume of a cylinder, and we have done with the volume under this curve, this one. Okay, so from the whole portion we have to subtract the volume under the curve. We will get the volume of a solid generated when the shaded region is only rotated. So for the shaded one, the whole volume minus the volume under the curve, we will get this one, right? Okay, so volume of shaded region when rotated 360 degree about x-axis. What is that volume? This is equals to volume of cylinder, the whole one, subtract volume under the curve. Under the curve. All right. So let me solve for the volume, which is volume of a cylinder is 7 pi by 5, and minus volume under the curve is 3 pi by 5, and 7 denominator is same, 7 pi minus 3 pi, this would be 4 pi by 5. That would be the volume of the shaded region when it is rotated 360 degree about x-axis. Question number 10, the equation of circle is this. The line with equation y equals to mx plus c passes through the point 0,9. Okay, so the line passes through the point 0,9. It means x is 0 and y is 9. So that is the y-intercept. So it means y is equals to mx minus 9 because c is the y-intercept, right? And is tangent to the circle. So tangent to the circle, it means touches the circle at one point, because tangent always touch the curve at one point, right? So it touches the circle. It means we have to put the circle and these two should be equal, right? Or we can say this is my y, and let me plug this into x minus 3 whole square. The y would be equals to mx plus minus 9 whole square equals to 18. So let me open the square. X square, 3 square is 9, minus 2 times 3 is 6x, plus m square x square, 9 square is 81, and 2 times 9 is 18, mx minus 18. This is equals to 0. So x terms are 1 plus m square. This is the coefficient of x square, right? So x are minus 18m and 6. So negative is 6 plus 18m. This is a coefficient of x, and the constant is 9, 81 and 18. 9 plus 81 minus 18, which is 72, plus 72, this is equals to 0. So it touches the circle at one point. This means discriminant is equals to 0. Discriminant is b square minus 4ac. this should be equals to 0. So let me solve for b square. So negative square is positive, 6 minus 18m, 6 plus 18m, b, minus 4 a value into the c value. Put this equals to 0. Find the two possible values of m. So from here we can easily get the two possible values of m because we will get a quadratic equation. So 6 square is 36 plus 18m. So 18 square would be 324m square, and 2 times 6 times 18, which is 216m, right? Okay, 4 times 72 is negative 288 times by 1, so minus 288 and minus 288m square. This is equals to 0. So these are the two square term. Okay, 324 minus 288, which is 36m square, and the m term is this 216m, and the constant is 36, and minus 288 minus 252, this is equals to 0. Okay, let me divide it by 6. It is divisible by 36. All the terms, yes. 36 over 36. Let me divide throughout the equation by 36. All the terms on both sides to make it easy. So this is just m square. 216 over 36 is 6 plus 6m. 252 over 36 is minus 7 equals to 0. Okay, factorization. 1 times 7 is 7. Okay, and 7 minus 1 is 6. Okay, m is common, m plus 7, minus 1 is common, m plus 7. This is equals to 0. So we have m plus 7 and m minus 1. This is equals to 0. So we will get two values of m. M plus 7 equals to 0, and we have m minus 1 equals to 0. So from here m is negative of 7 and m is equals to 1. So these are the two values of m, okay, which is 1 and negative 7. For each value of m, find the coordinates of the point at which the tangent touches the circle. We have to find the x and the y coordinates when the tangent touches the circle. So we will easily get the y coordinate by plugging the x values over here, m values over here, m and the x, yes, both values. So let me solve for x first. Okay, use this equation. Okay, so we can say put m equals to negative 7 in equation star. Okay, so we have 1 plus minus 7 square is 49 x square, plus minus 6 minus 18 times minus 7 x plus 72 equals to 0. Okay, 18 times minus 7 plus 6 and minus, it's positive 120. This is 50x square plus 120x and plus 72. This is equals to 0. Let me simplify this. Let me simplify this equation by dividing by 2. 50 by 2 would be 25x to the power of 2. 120 by 2 is 60x, and 72 divided by 2 would be 36 equals to 0. Now these terms are divisible by 2, but this is not divisible by 2. It is divisible by, let's see, 25 is divisible by 3. No, it is divisible by 5, but 36 is not divisible by 5. So this is 5x whole square, and this is 6 whole square, plus 2 times 5x times 6. 2 times 5 is 10, and 10 times 6 would be 60. Okay, so this is 5x plus 6 whole square, a plus b whole square formula, right? Okay, so now we have this whole square equals to 0. It means we have 5x plus 6 equals to 0, and we have x is equals to negative 6 over 5. This is the first x coordinate. Now let me put m is equals to 1 in equation star. Okay, again in equation star I'm putting m equals to 1. This is my equation star, right? I'm just putting m equals to 1. So 1 plus 1 square, this is the coefficient of x square, minus 6 plus 18 times 1, x plus 72 equals to 0. This is 2x square minus 6 plus 18, I guess 24. Yes, it's 24 x and plus 72 divided by 2. So x square minus 12x and 72 divisible by 2. Yes, it's 36. This is equals to 0, equals to 0. This is x whole square and this is 6 whole square minus 2 into x into 6, because 2 times 6 is 12 and it is negative, and this is a formula of a minus b whole square. So x minus 6 whole square equals to 0, x minus 6 equals to 0, so x is equals to 6. So these are the two x coordinates. Let me plug these two x coordinate into this equation. We can say equation star prime. Okay, so let me write down this equation. So y equals to mx minus 9, right? So when this is the x value corresponding to m equals to negative 7, and this is the x value corresponding to m equals to 1. Okay, so let me solve the y. So y equals to, when m is minus 7, the x is minus 6 by 5 and negative 9. And the second is y equals to, when m is 1, the x would be 6 and minus 9. Let me simplify both. So negative and negative becomes positive. 7 times 6 by 5 and subtract 9, this is minus 3 by 5, and we have 6 minus 9 is negative 3. So we can say the two coordinates xy. Okay, so x is minus 6 by 5 and the y is minus 3 by 5, and the other one is when x is 6, y is negative 3. So these are the two coordinates of the point at which the tangent touches the circle. Question number 11. A function f of x is defined by where x is not equals to 0. The graph of y equals to f of x is shown in the diagram. So that is the graph number A. Find the set of values of x for which f of x is decreasing. Okay, so when the function is decreasing when the first derivative of function is less than 0, right? Let me solve for the first derivative, f prime of x, right? So we have 4 and the derivative of 1 over x cube we have to solve. So if I can say d over dx of x to the power minus 3, negative 3 is outside, d over dx of x to the power minus 1, and plus the constant derivative 2 is just 0. So we have 4. Applying the power rule, so first we have a power, the base function, we have a power minus 1, minus 3, we have a power rule, x and power minus 1. Okay, so this is negative 12 over x to the power of 4, negative positive 3 over x to the power of 2. This is my first derivative, right? So this is minus 4, so shift in the denominator. This is minus 2, I've shifted in the denominator. All right, for decreasing function, its first derivative f prime of x should be less than 0. So it means minus 12 over x to the power 4 plus 3 over x square. This should be less than 0. All right. Let me make the same denominator. So it is minus 12 plus 3x square over x to the power 4. We have the same denominator is less than 0. So this implies minus 12 plus 3x to the square is less than 0, and 1 over x to the power 4 is less than 0. So from here we can take 3 is common, yes. So x square minus 4 is less than 0, or we can say x to the power 4 is greater than 0, or x should be greater than 0. Okay, and from here 3 is not equals to 0, so we can say x square minus 4 is less than 0. So now let me simplify. X square minus 4 is equals to 0. So the factors are x plus 2 and x minus 2. This is equals to 0. X plus 2 is equals to 0. From here x is equals to negative 2. And x minus 2 is equals to 0. From here x is equals to plus 2. Right, so between 2 and plus 2 the function is decreasing, right? So if I can let me visualize this situation. So let me draw this parabola, because we have the two roots. We have the parabola. Okay, this is a quadratic equation, x square minus 4, right? The two factors are plus 2 and minus 2, so this would be the shape of the parabola, right? This is 2 and this is minus 2, and when it is less than 0, when the value is between minus 2 and plus 2, right? Okay, so we can say x square minus 4 is less than 0 when minus 2 is less than x is less than 2, right? Okay, and we have given that find a set of values of x when the function is decreasing. So as you can see here, the y values are constant. Here we have increasing, and then the y values are decreasing, right? So it means at this point we have minus 2, the y values are decreasing. Here the y values, okay, from this point the y values are decreasing. Sorry, the y values increased in this direction and now it start decreasing. So let's say this is x is equals to 2, right? Okay, so it means between 2 to 0 the function is decreasing, but we have given the condition that x should not be equals to 0, right? So between 2 to 0 the function is decreasing, or between 0 to 2 the y values are decreasing, and here the y values are going to be constant, right? So here the y value is constant, it increase and then it start decreasing. So at x equals to minus 2 it decrease, and the y values are constant, it slightly increase and then the constant, and here the y values decrease when the x is between 0 to 2 and minus 2 to 0. Or we can write down the interval in the same way, and we can just say x is not equals to 0. And there is another way to write down the answer, that we can say minus 2 is less than x is less than 0, and we can say 0 is less than x is less than 2, and that is, these are the two ways to write down the answer that the function is decreasing. Now for part B, a triangle is bounded by the y-axis. Okay, I will draw the triangle later. The normal to the curve, we have the equation of curve. The curve is y equals to 4 over x cube minus 3 over x and plus 2, where x is not equals to 0. Okay, the normal to the curve at a point where x is equals to 1. Okay, so when x is equals to 1, what is the y value? The y value should be 4 over 1 minus 3 over 1 plus 2. So this is 4 plus 2 minus 3. This would be 6 minus 3, and this would be equals to 3. So we can say xy is going to be, when x is 1, y is 3, right? So let me write down the equation of normal. Okay, so for equation of normal we need the derivative dy over dx as well. Dy by dx, we have done the derivative in the first part. Yes, that is the derivative, dy by dx. Let me rewrite this. This is negative of 12 over x to the power 4 plus 3 over x square. That is the derivative. So now let me find dy by dx at x is equals to 1. Right, so minus 12 over 1 to the power 4 is 1, plus 3 over 1 to the power 2 is also 1. So minus 12 plus 3, this would be equals to negative of 9, right? Let me write down the equation of normal. So equation of normal, it has the formula y minus y naught equals to negative 1 over the gradient x minus x naught. Okay, so what is x naught, y naught? This is x naught, this is y naught. So y minus 3 equals to negative and the reciprocal of this gradient. So negative 1 over minus 9 x plus x minus 1. Yes. So negative and negative is cancelled. So y minus 3 equals to x by 9 minus 1 over 9. All right, now let's do the cross multiplication. So we have 9y minus 9 times 3 is 27. This is equals to x minus 1. 9y minus x, this is equals to minus 1 plus 27. So 9y minus x is equals to 26. So 9y should be equals to x plus 26. This is my equation of normal, right? Now the next part of the question says, and the tangent to the curve at the point where x is equals to minus 1. Let me find the equation of tangent, right? So for equation of tangent, we can say when x is equals to minus 1, what is my y value? Let me plug this x equals to minus 1 into the curve and solve for the y. Okay, this is the curve, right? I'm plugging over here. So what is y? Y is 4 over minus 1 whole cube minus 3 over minus 1 and plus 2. This is 4 over minus 1. This is minus plus 3 and this is my plus 2. This would be minus 4 plus 3 and plus 2. So minus 4 plus 5, that is equals to 1, right? So the points for the equation of tangent x naught, y naught, these are going to be minus 1 and 1, right? Let me write down the equation of tangent now, right? The equation of tangent So the equation of tangent is going to be, we can say y minus y naught equals to m into x minus x naught. So we have x naught, y naught, which is minus 1, 1. And what is the slope at x is equals to minus 1? So m is the gradient at x is equals to minus 1. We have minus 12 over minus 1 to the power 4 plus 3 over 1 to the power 2 minus 1 to the power 2. This is again the same, which is minus 9. All right, let me plug into the formula. Y minus 1 equals to negative 9 into x plus 1. Because x naught is negative, it becomes positive. Let me solve. So y should be equals to minus 9x minus 9 plus 1. So y equals to minus 9x minus 8. This is my equation of tangent. All right, now the question says we have a triangle is bounded by y-axis, the normal to the curve at a point where x is 1, and the tangent to the curve at a point where x is equals to minus 1. Find the area of the triangle, give your answer correct to 3 significant figures. All right, so as we know, tangent is always perpendicular to the normal, right? So let me write down. So the 3 legs of the triangles are basically the tangent, the normal, and the y-axis. All right, look at the diagram. We have a tangent at x equals to minus 1. All right, so let's say there is a minus 1 over here. This is a minus 1. Okay, this is a tangent at x is equals to minus 1, and the y-intercept for the tangent, this is the equation of tangent we have done. Its y-intercept is negative 8. So you did, this is the y-intercept, which is minus 8, and here x is equals to minus 1. Right, and we have an equation of normal at x is equals to 1. So as we know that tangent is perpendicular to the normal, so it should be perpendicular to the normal, right? So this is perpendicular to the normal, and this point we can say here x is equals to 1. There x is 1. Okay, and it is also bounded by the y-axis, so this y-axis. So that is the shape of the triangle, a right angle triangle, right? Okay, and we have the y-intercept for the equation of normal as well. Okay, for equation of normal, what would be the y-intercept, which is 26 over 9. What is 26 by 9? Okay, 26 by 9 is 2.8. Okay, this is 26 by 9 or 2.88, right? We have to find the area for this triangle. So that is the shape of the triangle. So we have equation of tangent at x is equals to -1 with this is the y-intercept, and the equation of normal at x is equals to 1 and the tangent is perpendicular to the normal and it is bounded by y-axis. So this is the triangle, right? Okay, so now we have to find, we have the y-intercept for tangent and for normal. We have to find the point of intersection of the tangent and the normal. So we have the equation of tangent and the equation of normal. This is 9y, or we can say from here y is equals to x over 9 plus 26 over 9. This is equation of normal, and we have equation of tangent. Let me find the point of intersection of the tangent and the normal. So we can say point of intersection of equation of tangent and normal. Okay, so now we have minus 9x minus 8, and the equation of normal is x by 9 plus 26 over 9. X over 9 plus 26 over 9. So let me combine the like terms. So 9x minus x over 9, and this is 26 over 9 and plus 8. Okay, so let me take x common. We have minus 9 minus 1 over 9, and here we have 26 over 9 and plus 8 would be 98 over 9. 98 over 9, and this is minus 9 minus 1 over 9. This is minus 82 over 9. Minus 82 over 9x is 98 over 9. So 9 is cancelled with 9, and what is x? X is negative 98 over 82. Okay, 98 divided 2, this is 1.195. Okay, x is equals to negative 1.195. All right, so this is a point of intersection. So we have the point of intersection of the tangent and the normal, which is negative 1.19, and this point of intersection, the x is negative 1.19512, right? Okay, so this would be the height of the triangle. Let me consider this as a height, and this distance, this would be the height, and that would be the base of the triangle, right? So for area of a triangle is half base times height. It is a right angle triangle, so we can use a base times height. This would be the base. Okay, so it is half. Let me find out the height. The height is from this point, which is negative 1.195, until 0. So this 0 minus of this becomes positive 1.19512, and the height is this distance. The base would be 26 by 9 negative 8 becomes positive 8. So 26 over 9 plus 8. Let me calculate this. 26 over 9 plus 8 times 1.19512 and times by 1. Okay, 1 by 2. So the area is 6.5, and we have to find the answer correct to 3 significant figure. This is 1. This would be the area. So I hope this makes sense now. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.